All right, so before we learn how to calculate confidence intervals, let's first try to get an understanding of what a confidence interval is. So if you saw a confidence interval, again, in an article or you hear about something in the news or whatever, would you know what it means? Okay, that's the first thing. So suppose we have a 95% confidence interval for the proportion of people who eat fast food at least once a week, and it is 0.65 is less than p is less than 0.73. Okay, so that's the inequality notation. You could also write it in interval notation. You'll actually see that in the next line. So if we were to do a statistical interpretation, or if you will, an academic interpretation, okay, what we would say is there is a 95% probability or chance that the interval 0.65 to 0.73 contains the true population proportion of people who eat fast food one or more times a week. So I'm going to say at least once a week. Okay, sorry, I didn't give you very much room on that line, did I? Okay, so there'd be a 95% probability or chance that the interval contains the true population proportion of people who eat fast food at least once a week. Now, the wrong interpretation is that there's a 95% chance that the true value of P, the percentage of people who eat fast food at least once a week, falls between those two values, 0.65 and 0.73, okay? That is wrong. So what you need to say is there's a chance that the interval contains it, okay? But don't say that the true value will actually fall between there. Why? Well, that's because the true value of P is fixed. There is a real number, a real proportion of people out there. If you could sample, let's say, again, ICC was our population. We're not going to sample the thousands of students at ICC to find the true population proportion, okay? But that number, whatever it is fixed. It's not moving. It's not going anywhere. That is the answer, okay? So what happens is we come up with an estimate. We sample 100 students to find out, and then we make our interval. The interval that we create, or calculate, if you will, either contains that true value of P or it doesn't. Okay, it's out there somewhere. So like, I don't know, with Easter being this just a couple days ago, it's where I'm making how you can tell the timeline that I'm making my videos. You hide an Easter egg somewhere and you go out to get it. You're either within 5 feet of that Easter egg or you're not. Okay, the Easter egg isn't moving. It is where it is. And so you either came within 5 feet of finding that egg or you didn't come within 5 feet of finding that egg. There is no like, well, maybe I did and no, you did or you didn't. Okay, it's not moving around. All right, the real world interpretation. So the one that you would use, again, if you're writing an article that's not a scholarly academic article or the type of thing you'll see, again, discussed on the news or whatever, is kind of more your real world interpretation. You don't have to mention that 95% probability or whatever, because this is just kind of your everyday talking, okay? So this would be the proportion of people who eat fast food at least once a week is between 0.65 and 0.73. Okay, and you would just leave it there. Okay, again, no probability attached to this statement because it's not a statistical interpretation. This is just kind of your everyday vernacular interpretation. Okay, so let's go ahead and try another one. And I would encourage you again to go ahead and pause the video, try to write down your interpretations now, and then come back and compare. Okay, for those of you who say I'm not pausing the video, well then just continue right on with me. Okay, So let's suppose we have a 95% confidence interval for the mean age a woman gets married in 2018, and it was found to be 27 to 29. Okay, so the statistical, turn my pen on, sorry. The statistical interpretation would be there's a 95% chance or probability, if you'd rather use that word, the interval 27 to 29 years old contains the true mean age when women marry. Okay. The real world interpretation would be something like this. The average age that women marry is between 27 and 29. Okay, so simple as that. So you've got one that's, again, a little bit more academic in nature, okay, and one that's just more commonplace. All right. Okay, so one more here. We have a 99% confidence interval this time for the proportion of Americans who have tried marijuana as of 2018. It is between 0.35 and 0.41. Okay, so the statistical interpretation, again, would be there's a 99% chance. Ooh, let's do chance. Forgot to write that word there. The true, now this is not a mean, okay, this is a proportion, so you can do the true proportion. You could say percentage as long as you write your answers as a percentage, but we'll say the true proportion of Americans who've tried marijuana, I'm going to write pot because it'll be faster, is captured in the interval 0.35. Oh, let me not write it in interval notation though. In the interval 0.35 to 0.41. Okay, you could say the true percentage of Americans who've tried pot is captured in the interval 35% to 41% as well. Okay, that's another option that's perfectly acceptable. All right, our real world application would be something along this line. 35% to 41% of Americans have tried marijuana, pot, whatever. Okay, so again, it's a little easier to do the real world interpretation, and that's fine, and it's all well and good. But again, in academic research, that statistical interpretation will become important. All right, in the upcoming pages, we're going to talk about that 95, 99% and what that means, and what those differences do to our intervals.